Our last conic section that we have to learn about is hyperbolas. And hyperbolas, if you look at them, they look very, very different from any of the other conic sections that we've dealt with. However, they're actually kind of similar to ellipses in a way. Bear with me here for a second. So ellipses, we talked about how the sum of the distances from any point on that ellipse, the sum of the distances to the foci is the same. Well, for hyperbolas, it's the difference instead. So any point on my hyperbola, that difference between those distances, the difference between your foci is the same. So in this case, it's showing you anywhere we are on our hyperbola, that distance 1, d1 minus d2 is always going to be the same. So that's where our hyperbolas come in. The hyperbola is a lot harder to do as a construction with string, so that's why we're kind of not really doing that. But we will, or anyway, hopefully seeing that animation will help you out a little bit. So we're going to go through some vocabulary here in section 5 before we get going with examples. And again, we have a lot of vocab to deal with. So in a hyperbola, again, here's our definition. All points where the difference in the distance between two foci is constant. Now the vertex, that really did not focus at all. Let's try that again. Okay, the vertex is the turning point of each branch. So if I look at my diagram on the side here, this is a vertex, and this is also a vertex. The transverse axis is the axis that connects the vertices. Kind of similar to our major axis and minor axis or ellipses. It's called the transverse axis. Now, the way that I like to remember the transverse axis connects the vertices is transverse, vertices. We see that part of the word there. So transverse axis in my diagram is going this way. I'll use a different colored pen here. Transverse axis goes this way. Okay, the center of a hyperbola is the midpoint between our vertices. So that is right here, between one vertex and another vertex, halfway in between, this is our center. This little diagram here is about to get pretty messy with our next words here and with our next vocab words. The conjugate axis is perpendicular to our transverse axis. And the length is 2b. This part will come back into play a lot more in just a second. The length of that conjugate axis is 2b. Our central rectangle last vocab word here is formed by our transverse axis. So I'm abbreviating that TA, transverse axis, and the conjugate axis, abbreviated CA. Now that central rectangle, I'm going to draw that in here. You might think, okay, what is the point of this central rectangle? The point of that central rectangle is that the diagonals create the asymptotes. Way back when we did our investigation originally with our conic sections, I mentioned that hyperbolas, they kind of look like parabolas, like two sides of a parabola, but really they're pretty different because they have asymptotes where parabolas don't. Hyperbolas have asymptotes, and it is these diagonals. Really, I should use a straight edge here. It is those diagonals that create the asymptotes. Okay, like I said, our diagram got pretty messy there. We also are going to look at our equations of our hyperbolas. And again, like what we did with our ellipses, there was a lot of vocabulary, but hopefully by the end, that vocab really wasn't too bad. Our two equations here. We have x squared over a squared minus y squared over b squared equals 1. Pretty similar to our ellipse. Main difference is that this is a minus instead of plus. This first equation, where the x squared comes first, is horizontal. This kind of hyperbola is horizontal. So that means it looks like this. Our other equation, y squared over a squared minus x squared over b squared, is vertical. Okay? Either way, we have vertices at plus or minus a. Whatever number comes first underneath is where our vertices are. So we have vertices at plus or minus a. 2b tells us the length of the conjugate axis. B itself doesn't really tell us a whole lot, but 2b is our length of the conjugate axis, and that tells us quite a bit more. And we also have foci at plus or minus c. I'm going to draw a little diagram out to the side here of a horizontal hyperbola. This is my hyperbola. A is where my vertex is. My whole conjugate axis is 2b. So b tells us that, I guess, the length from the origin out to the top, out to the end of my conjugate axis. And then our foci is at C. Now we have kind of a similar situation that we had with our ellipses, where we have a right triangle that's formed here. And again, this length of our hypotenuse is also our length from our origin out to our focus. So that comes into play a lot as well, just like it did with ellipse.